Question 10 of the worksheet on inclined planes. A particle of mass 0.5 kg starts from rest and slides down the line of greatest slope of a smooth plane. Okay, that means friction is zero. There's no friction if the plane is smooth. And here's the inclined plane, 30 degree, and it starts from rest. So u is equals to 0, and it goes down the plane. So these two would be the components of the weight. This one is always mg cos theta. So g is 10. So this is going to be 10m cos 30. This one would be mg sine 30. So 10m sine 30. Since the plane is smooth, there's no friction in the backward direction, and normal contact force is always in this direction. Okay, so find the time taken for the particle to reach the speed of 2.5 meters per second. So u is 0, it starts from rest, eventually it reaches a speed of 2.5, and we need to find the time for this. And this system can help us find the acceleration using Newton's second law. Forward force minus backward force is equals to ma. Forward force is 10m sine 30. Backward force is 0. That is equals to mass times acceleration. Mass and mass cancels out. Acceleration would be equals to 5 meters per second square. Okay, we now also know the acceleration here. Okay, now we can use v is equals to u plus at to find the value of t. So 2.5 is equals to 0 plus 5 times t. This would be half seconds. T would be 0.5 or half seconds. Okay, so we also know the time here, 0.5 seconds. Okay. When the particle has traveled 3 meters down the slope, so it starts from its starting point, it reaches a rough horizontal ground. Okay, so this distance from here to here is 3 meters. After that, the ground becomes rough. That means now there's going to be a backward force of friction because it's a rough surface. Okay. The frictional force acting on the particle is 1 Newton. So this is the 1 Newton force. Now there's no forward force. Earlier, this was the force in the forward direction. This was the component of weight, but now this will cease to exist because it's a horizontal surface. Instead, we're going to have weight in this direction, which is just mg now, which is going to be, m was given in the question. I did not substitute it. We could have substituted it here and here, and it would have canceled out anyway. Anyway, this is mg, so m is 0.5, g is 10, so this is 5 newtons. And opposite to that is r, and since they're equal, r is also equals to 5 newtons. But again, we might not need it. Let's see. Okay, so now it says find the distance that the particle travels along the ground before it comes to rest. So now the particle is going to come to rest somewhere over here, let's say, and v will be equals to 0. So you know v is 0. Also, let's find the speed here so that we can call it u is equals to something for this part of the journey. Okay, so going back to this, we can use u is equals to 0 at the top. V is equals to question mark down the slope. A is going to be 5. And S is 3 meters. Let's use that and find V. So V square is equals to U square plus 2AS. So square root U square plus 2 times 5 times 3. So this is going to be square root of 30. So that's the V here, square root of 30. And for this journey, this is going to be U. So let's call it U is equals to square root of 32. So this is going to be square root of 30. And we need to find the distance. S is equals to question mark, this horizontal distance. And now we still need to find the value of A, because now the acceleration is going to be different. We're going to use Newton's second law on this system. Forward force minus backward force is equals to ma. Forward force is 0, backward force is 1, mass is 0.5. So A is going to be minus 1 upon 0.5, which is going to be minus 2 meters per second square. Okay, so now we have the acceleration as well. So we have to find S. We can use v square equals u square plus 2as again. So 0 square is equals to under root 30 whole square is going to be 30 plus 2 times minus 2 times s. So we can write 4s is equals to 30 and s is equals to 30 by 4, which is going to be 7.5 meters.